their own build system. So if you release your own software, they will build it and index it for you so others can find it. So this sounds like a really great thing for the robotics research community, and it has been. You can see it started in 2008 and has seen exponential growth in the robotics research community. To the extent that now almost all, and that's maybe a little bit of a hyperbole, but most robotics research labs either are using ROS or they know about it. And this is really a game changer for the robotics research community, because now you can share code, you can compare it, you can advance the state of the art without having to reverse engineer everything that came before you. It really is pushing robotics research forward. So over 3,000 software packages now which have been released under ROS. Really exponential growth. So what can you do with it? So this is a video that Will Garage put out, which is just a montage of systems and programs that are using ROS. And this is only after the first 3 years. There's many more after this. If you search YouTube, you'll find lots of videos like these out there too. Well, suffice to say, ROS runs on a lot of different hardware systems and does a lot of different things. It's running on underwater robots, it's running on aerial robots, it's running on ground robots. It's doing navigation, it's doing manipulation research, it's doing grasping research. It's literally been ported to just about every robotics research platform out there. So one of my favorite applications, and we'll see if this video works, is this one, which is towel folding. This was done at Berkeley, and Mr. Singh was involved, at least this comes out of his lab, so he can probably tell you more about it than I can. It's a really, really hard problem for robotics. So you're dealing with deformable objects, which is incredibly difficult to sense. Humans do this naturally, robots not so well. This is the PR2 robot. It's built by Willow Garage. They gave out 11 of them to research labs around the world. As I mentioned, this one happens to be at Berkeley. So this is a combination of kind of everything that is built into ROS. There's perception, there's planning, there's task management, there's visualization and simulation. Really incredible work. So I invite you to look on YouTube. You'll find many more. Search for PR2 or ROS. So the one thing you didn't see there was many industrial robots. Right? They were all kind of research grade robots or humanoid or lots of university research. And we at Southwest Research are involved in taking basic research and pushing it into application space. So we saw this lack of adoption of ROS within industry and commercial applications as a real opportunity. So about a year ago, we started collaborating with Willow Garage and started this program we're calling ROS Industrial, which is fairly descriptive, taking all the good stuff in ROS and trying to port it to industrial applications. So the first thing we need to do is build more or less hardware drivers so that you can take this whole ROS environment and get it to run on industrial robotic systems. And we've already done that, and now we're extending it. So we'd like to take it to things like PLCs and industrial sensors. We'd like to extend it to industrial protocols, OPC, network-based I/O, and those types of things. We're actually building a consortium around this idea to help develop and further the technology and to build community around bringing ROS to industrial and commercial applications. So if anybody's interested in that work, please see me after the talk here, and I'd be happy to discuss that. So the third topic is mobility. So there's been a lot of research in the last decade or more in mobile systems, mobile robotics. A lot of that has been driven by the Department of Defense, but in reality, a lot of it comes from the mobile industry. So your smartphone has a lot of the capabilities that are required to drive a robot, right? So this thing's got GPS in it. It's got a low power, high performance processor. It's got an IMU, essentially an inertial system in it. It's got gyros, it's got cameras. It's got pretty much everything you need to build a robot. So the mobile industry, mobile communications industry, has really helped drive mobile robotics because it's made a lot of those technologies better and cheaper. In addition, there's been a lot of great research. So I mentioned the DoD. The picture at the top there is the DARPA Grand Challenge. It was first run in 2004. Nobody finished. 2005, Stanford University finished first. That's their Stanley vehicle. Drove over 100 miles through desert terrain all by itself. Pretty amazing work. In the middle there is an EOD robot. That's explosive ordnance disposal. It's a PackBot made by iRobot Corporation. Lots of research has gone into making those things reliable and easy to use, and they've saved hundreds of lives in our military hot zones. And one of the things that is probably most exciting to me is organizations like FIRST Robotics, which are bringing robotic development into high schools and now even into elementary schools. I think that bodes very well for the future of robotics in the U.S. So these are just some applications that we're working on in the mobile space to kind of give you a flavor of what's possible and what's going on. And Mr. Singh, he'll show us some more exciting mobile systems here in a little bit. This is a company called ICM, International Climbing Machines. We're partnering with them to develop payloads for inspection technologies. But they have a really unique technology, which is basically this climbing robot. It uses suction or vacuum to be able to climb surfaces, even horizontal, vertical, can climb over rock, stucco, brick, steel. So there's a lot of interest in very large-scale applications or areas where it's difficult to get human access, such as wind turbine inspection. We're also extending mobile manipulation or industrial manipulation to the mobile space. So most industrial manipulators are fixed-base manipulators, right? You bolt them to the ground. Well, that's okay if you're dealing with small objects that you want to manipulate. But when you start wanting to deal with like aerospace applications, which we do a lot of, you either have to build these really big robots like the one that I showed you at the very beginning, or you make them mobile. So take a small robot, put it on a mobile platform, and now you have a capability of managing a much larger workspace. This is some research that we're doing where we're tying an industrial manipulator, a mobile platform, and a laser-based metrology system, tying those together so that we can do large workspace, high accuracy manipulation. So rather than being able to just deal with things on the scale of meters, we're dealing with tens or hundreds of meters in scale. So we've also been partnering with the Electrical Power Research Institute, SWRI, to develop inspection robots. So this one on the lower left here is a robot that's designed for inspection of power transmission lines. So this guy is designed to traverse hundreds of miles a year and take various sensor data on power transmission lines. So in the middle here is a picture of a LiDAR sensor map. It's basically a three-dimensional map that's built up around a transmission line. And that type of information is useful to get basically you can do things like change detection to see if there's been encroachment on the right-of-way for the transmission line. It also has cameras on board. It's got a weather station, GPS, obviously. It will have thermal sensors for doing various types of inspection.